Alright, so let's start out with distance, displacement, speed, and velocity. Some big questions we're going to answer as we go along. What is distance? How is displacement different from distance? What is speed? And last, what is velocity? We're also going to touch on scalars and vectors. Alright, so distance. Here we go, we got a little ant. How far an object travels. In this instance, the ant. It does not depend on direction. Very key. So we got this ant. Here he goes along the ruler. What's the distance that the ant traveled? I'll give you a second. Exactly, 3 centimeters. Remember, doesn't depend on direction. So here's how we interpret the ant explorer again. Or here's our intrepid ant explorer again, sorry. What distance did the ant travel? Exactly, 3 centimeters. Does his direction change the answer? No, it doesn't. Alright, so distance does not depend on direction. Let's follow the ant again. There he's off, traveling along, comes on back. Oh, look at that. What distance did the ant walk this time? Exactly. He walked 7 centimeters. 5 and then 2. 7 total. Alright, so displacement. A little different. Displacement is our change in position, our delta x. That is our change in position. Difference between the object's final position and starting position, also initial position. It does depend on direction. Very key. Does depend on direction. So final position minus initial position. Formulaically, as a formula, the change in x, or change in position, is equal to position final minus position initial. Pretty straightforward. In order to find displacement, we need directions. Examples of directions we use: plus and minus, left and right, up and down, north, east, south, and west, or angles. Alright, so let's look at some examples of distance. The ant walked 3 centimeters. Displacement: the ant walked 3 centimeters east. Notice the direction at the end, east. An object's distance traveled and its displacement are not always the same. Very key. Alright, so here we go. Here's our little ant again. Let's find his displacement this time. Here he goes, off to the races. His distance, 3 centimeters. What was his displacement? Plus 3 centimeters. Direction, plus 3. The positive gives that ant direction. Very key. Alright, here we go. Remember, displacement has direction. Start from 3, we head back over to 0. The distance he traveled, still 3 centimeters, right? However, the displacement he traveled is negative 3 centimeters. Alright, here he is again. Goes out to 5, turns around, comes back to 3. Okay, we've seen this before, right? Distance, 7 centimeters. But his displacement is positive 3 centimeters. He started at 0 and ended at 3. So we take his final position of 3 and subtract it from his initial position of 0. 3 minus 0 is positive 3, his displacement. Alright, now let's look at a runner on a track. An athlete runs around a track, it's 100 meters, it's indoor track. He runs around 3 times and then stops. we're going to ask what is his distance and his displacement. There he goes. He's off to the races. Round in the corner. He comes back around. Oh, it's a heated race between him and himself. Here he goes again. Okay, coming into that last lap, we got the white flag. He's coming around. He's coming around turn 2. Here he is. And he wins, of course, right? Nobody else was competing with him. All right, so what's his distance? Pretty straightforward, right? 3 laps, 300 meters. But his displacement was what? He started here. He ended here. So we take a number, we subtract it from itself. We get what number? 0. Our displacement was 0 meters. His final position and initial position were the same thing. One minus the other is 0. Why is that? Okay, ask yourself. All right, so now we're going to talk about speed. All right, real quick. No pun intended. Speed, the rate at which an object is moving. Right? You've all heard the term speed before. It's just distance over time. Distance divided by time. Formula S equals d over t. Like distance, speed does not depend on direction. Your speedometer in your car tells you how fast you're going. It doesn't tell you if you're going north, east, south, or west. All right, here we go. Speaking of your car, you're going to drive 100 meters in 5 seconds. That same track. All right. So what is the car's average speed? 100 meters distance, 5 seconds time. Distance divided by time. 100 meters divided by 5 seconds is 20 meters per second. Everybody good? I think so. Pretty straightforward. All right, we got a rocket. It's traveling 10 kilometers per second. How long does it take the rocket to travel 30 kilometers? It's pretty straightforward. If we go 10 every second, we got to go 30 of those. 10, 10, 10. How many seconds? Watch the video to find out. Maybe use a stopwatch or calculate it out. All right, now we got a race car traveling 85 meters per second. How far is he going to travel in 30 seconds? Not as straightforward, right? But we can use our dimensional analysis we learned prior, and we can just multiply 85 by 30 seconds. It cancels out our seconds. We're left with distance we traveled in meters. We're rearranging that 3-variable equation. All right, so speeds. Also, we go on to speed with direction, which we call velocity. Velocity is our displacement over time. Notice, not our distance over time, but our displacement over time. Our change in position divided by time. All right, there's our Anakin. This guy's at it again, huh? Look at him go. Oh, he took a while to turn around. Oh, okay, made it back. All right, so now he's traveled that distance of 7 centimeters before, right? Displaced the positive 3 centimeters. Nothing's changed there. But now we can calculate his speed because we know the time it took him to do this. His speed is that distance, 7 centimeters, divided by that time, 5 seconds. We get 1.4 centimeters per second. If you want to be a real stickler on sig figs, it'd round down to 1 centimeter per second. Velocity is displacement divided by time. His velocity is at positive 3 centimeters divided by 5 seconds. What is that? We get 0.6 centimeters per second in the positive direction. In the positive direction. All right, so I said we were going to talk about scalars and vectors right at the end, right? So a scalar quantity has a magnitude but non-direction. It has that value, but no direction component. Distance and speed were both scalar quantities. They just had 3 centimeters, 10 meters per second. There was no direction associated with it. Yes, there was a unit, but there was no direction associated with that magnitude, with that size. However, vector quantities have a magnitude and a direction. We talked about displacement and velocity. Displacement, the ant went positive 3 centimeters, right? Velocity, the ant went positive 0.6 centimeters per second. The positives were our directions there. We could have said east or west or up or down, left, right, any of those things associated with direction. Okay? All right, so that's all.